Hi everyone, my name is Uheb. In this tutorial we will learn about frames and how to calculate frame sizes for grid items. We are starting with a grid containing 64 items distributed in rows with 8 items per row. The mask and stroke frame features were added to the grid. These frames act like cells in Excel with each item centered within its frame. The stroke frames feature adds a visual reference around each grid frame, which we will remove shortly. Currently, the items have gaps around them. To fill the entire grid frame, we will set the items fitting to fill the frame, which ensures that excess pixels are cropped. This is why we added the mask frames feature. Let's now remove the stroke frame feature from the frame features dialog and click on update. There are two methods for calculating frame sizes in a grid: number of items and frame size values. Let's explore each method and its use cases. With the number of items method, we specify how many items should be visible inside the composition. The frame sizes are then automatically calculated to fit the items within the composition. These frame sizes will compensate for margin values, ensuring they fit within the composition perfectly. I set the margins to 10. It is important to note that if you have selected the row distribution type, the number of items invisible per row should not exceed the total items per row. Otherwise, empty frames may be generated as no items are distributed there. The same logic applies if you have chosen column. The visible items per column shouldn't exceed the number of items per column. For example, with 8 items per row, setting number of visible items per row to 10 results in 2 empty columns. If you need 10 items to fit within the composition horizontally, you should also set the number of items per row to 10 or a higher value. Since we have 64 items, increasing the number of columns makes the items move into previous rows, so we need more items to fill the new spaces. Now let's make some adjustments. Set the number of items per row back to 8 and set the number of visible items per row and column to 4. This will set the 4 items per row and 4 per column to be visible inside the composition. The remaining items remain outside the composition, which can be animated later using properties like offset and position, etc. Enabling the animatable values option allows you to animate the grid to show different numbers of visible items over time. For instance, start with 3 by 3 items visible in the composition. Add keyframes for both visible items per row and column. At 2 seconds, adjust the values to 8 and 4. Apply easing for smooth transitions. When you play the animation, the frames automatically adjust to fit the new number of visible items, and items scale proportionally to fill the frames. This checkbox ensures smooth value transitions between frames. Otherwise, values are rounded, causing the frames to always fit, resulting in an abrupt appearance during animation. Let me show you another example. Let's play this. Here I've combined the animation of visible items per row column with items per row column. On the first keyframes, visible per row column are set to 3 by 3. On the second keyframes, the values are 8 and 4. Items per row column value is animated from 3 to 8. Initially, there are just 3 columns, which then increase to accommodate the visible items per row. This avoids blank frames and creates a seamless animation as items move into previous rows when the number of items per row column changes. I have moved the first and last keyframes inward slightly. This ensures they start animating a bit later and finish before the visible per row column animation completes, creating a polished look. I have also added some position and rotation keyframes. The first and last keyframes have their values set to 0. On the middle keyframe, the position is adjusted slightly towards the right and bottom. The rotation is tilted slightly to the right. I have reduced the duration between these keyframes to account for the delay, which adds extra frames for the animation of all items. This ensures the transform animations closely align with the visible per row column keyframe animation. I have selected delay by distance and set the delay in frames value to 3. This way both transform properties, position and rotation are affected by this delay. I have positioned the delay center near the center of the first item, causing the position and rotation animations to begin there and progress toward the bottom right of the composition, guided by the longer distance. The animation now has a creative flow by combining these properties. You can experiment further with different settings to craft your unique animation. Let's move to the previous composition. The second method is frame size values, in which we can calculate frames based on exact pixel dimensions. For our grid, the frame sizes are set to 1920 by 1920 pixels, which were calculated while creating the grid. But the frames appear smaller in the composition. It is because the grid frames are scaled while maintaining their proportions to fit the grid to the composition on one axis, depending on the selected grid fitting option. Currently, these frame sizes function more as ratios between the width and height of the frames. If you want to calculate exact frame sizes, select the No Fitting option. Now you can see the items with precise 1920 by 1920 pixel values. To achieve a perfect fitting of items, we need to calculate frame sizes by dividing the composition's width and height by the number of items per row and column to be visible inside the composition. I remove the margins for now. For example, for a 4x3 grid, we divide the composition width by the number of visible items per row, which is 4, to get the frame size X, and divide the composition height by the number of visible items in a column. Now you can see the items fit perfectly within the composition. You can also animate different numbers of items to fit within the composition by calculating the frame size values and adding keyframes, similar to the number of visible items method. However, if we add margins, you will notice the items moved outside the composition because margins are not included in the frame size values method. You can achieve the same results with a bit more effort in this method. Therefore, you will need to account for margins by adding them to your calculations or manually adjusting the frame size until they fit properly within the composition. To adjust manually, I am decreasing the frame size X until the frames fit within the composition, and do the same with frame size Y. To achieve this through calculation, we need to multiply the value of margin X by the number of items per row plus 1. We add 1 because with 4 items per row, there are 5 vertical margins around them. Next, subtract the value of total margin X from the composition width. This gives the remaining space for our items after excluding margins. Now, divide this by the number of items per row, that is 4. We get a value of 455 for frame size X, which matches the value we adjusted manually. You can use the same method to calculate frame size Y. So you have two options: adjust it manually or calculate by subtracting margins. Choose whichever is convenient for you. The calculation method you choose depends on your project's needs and convenience. Use the frame size values method when you need to calculate frame sizes with exact pixel dimensions. or select the number of items method, which automatically calculates frame sizes and margins by simply adjusting the number of visible items. As we have already checked the no fitting grid fitting option, which allows us to use the exact frame sizes specified here. The other grid fitting options scale the frames to fit the grid within the composition, and margins need to be adjusted manually. Let's now explore some other grid fitting options and what they do. Let's select fit by width. In this method, the grid will fit horizontally within the composition and the items may overflow from the bottom. If you choose fit by height, the grid will fit vertically within the composition and the items may overflow horizontally. In the fit by width and height method, the grid will scale either horizontally or vertically depending on its overall size in that direction. If the grid rows exceed the composition more than the columns, it will scale horizontally. Or in case of columns exceeding the composition more, the grid will scale vertically, ensuring all items remain inside the composition. The margins are calculated in the direction of grid fitting. In fit by height method, horizontal margins are included in the grid fitting. So you may need to adjust the frame X or Y size value to fit the items horizontally. I will decrease the value until the margins fit inside the composition. Now these are fitting properly. Now let's look at the items fitting options. These options apply to both the frame size values and the number of items methods. I will set the margins to 5 for clarity. For items fitting, we have selected fill the frames, which scales items proportionally to fill their entire frames. This may cause parts of the items to extend beyond their frames. However, with the edit mask frame feature, any excess pixels are clipped. If you haven't added the mask frame feature yet, you can do so by opening the frame features dialog and enable it from here, then click the update button. If we set it to fit to frames, the items will scale proportionally to fit within their frames without exceeding the frame's boundaries. Next we have fit by width and fit by height, which are self-explanatory. In these options, items will fit their frames in the selected direction and the other direction may extend beyond the frame's boundary if the item is larger. Now let's select stretch to fit. In this method, items do not exceed their frame boundaries but are stretched to fit exactly within their frames. This may cause distortion, but it works well for the items where the distortion is not noticeable. You don't need to use the mask frame feature with fit to frames and stretch to fit methods because in these methods items do not exceed their frame boundaries. And a grid without any frame features performs better when working with a large number of items. However, if you are working with the text, shape layers or any other elements where stretching is noticeable, we will use the mask frame feature. And in the no fitting method, the items retain their original 100% scale values. As you can see, all items are extending beyond their frame's boundaries, but they are clipped by the mask frame feature. So we have now discussed all these items fitting options, and you can choose the one that best suits your needs. I hope this tutorial was helpful, and don't forget to subscribe for more updates and future tutorials. Thanks for watching and see you next time.